Good morning, boys. Today we are going to continue on equivalent fractions, but instead of creating equivalent fractions by multiplying both the numerator and the denominator by the same number, today we're going to divide the numerator and the denominator by the same number, and that is called simplifying fractions. So today's lesson is on simplifying fractions. So as we said, we can also obtain a pair or a group of equivalent fractions by dividing both the numerator and the denominator by the same number. Just like it was important yesterday that we multiply both the numerator and the denominator by the same number, when we divide the numerator, we need to divide the denominator by the same number. It's very important. And this is called simplifying a fraction. Let's look at the fraction 18 on 21. 18 on 21 can be divided by 3. I can divide the numerator by 3. 18 division by 3 is 6. 21 is also a factor, is also a multiple of 3, okay? So we can divide 21 by 3, which is equal to 7. The fraction becomes 6/7, okay? It cannot be divided by the same number. Numerator and denominator cannot be divided by the same number anymore. So that's the simplified fraction. We can say that 6/7 is the simplified fraction. So to simplify a fraction, we need to divide, means dividing both the numerator and the denominator by the same number until it cannot be divided anymore. Okay? Now we have a picture of a pizza. The pizza was first divided into 8 pieces, okay? And 4 pieces were eaten, okay? So 4 eighths were eaten, okay? The other 4 eighths are not, okay? Now, the pizza was then divided into 4 quarters, okay, into 4 parts, 4 equal parts, and 2 pieces of those 4 parts were eaten, okay, and 2 are left, okay. So the fraction of pizza which was eaten was 2 parts, 2, out of a total of 4, okay, and that's why it is 2/4. In the last case, we have a pizza divided into 2 equal parts. Only 1 part was eaten, so 1/2 was eaten, okay, 1 out of 2. Since it is the same, if you look at the 3 diagrams, you still have the same amount of pizza, 1/2 of the pizza, okay, but the first case the pizza was divided into 8 parts. In the second case, the pizza was divided into 4 parts, and the third case, the pizza was divided into 2 parts. Now, they are equal, right? Although the fractions appear differently, they are equal, all right? So they are 3 equivalent fractions, a group of equivalent fractions. Now, to obtain a 2, I divided by 2. Okay, the 8, to obtain a 4, I divided by 2. The 2/4, to become a half, I divided again by 2. 2 division by 2 is 1. So the denominator, I must divide it also by 2. And 4 division by 2 is half. Okay. Now, when we divide top and bottom by the same number, we are, as we know, we are creating an equivalent fraction, and that's why we put down an equal sign, all right? So if I have an example, the fraction 8 all over 20, okay? 8 all over 20 can be simplified because both 8 and 20 are multiples of 4. So I divide the 8, the numerator, the 8 by 4, which is equal to 2. And I divide the 20, the denominator, by 4, which is equal to 5. But as we discussed yesterday, and the fraction becomes 2/5, okay? But as we discussed yesterday, 4 all over 4, right? 4 division by itself, 4 division by 4, 4 all over 4, is equal to 1, right? 4 division by 4, 4 all over 4 is equal to 1. Now when dividing a number by 1, the number remains the same. We get the same number. For example, 5 division by 1 is 5. 100 division by 1 is 100, okay? 1000 division by 1, it's 1000. Oh, okay. So that is why when we multiply both numerator and denominator by the same number, we end up with a fraction which, although it looks different, it has the same value because we are dividing by 1 eventually, okay? We are actually dividing by 1. If we divide both the numerator and the denominator by the same number, we are dividing by 1. So that's why we obtain a pair or a group of equivalent fractions, which, although they appear differently, all right, they still have the same value. It's important. They have the same value. Now, simplifying a fraction in maths is also called reducing a fraction to its lowest terms. Lowest terms means it cannot be simplified anymore, right? It means that I cannot find another number which divide exactly into both the numerator and the denominator, okay? So instead of being asked simplify a fraction, you can be asked to reduce a fraction to its lowest terms, okay? Now, the important rule, as we said, to reduce a fraction to its lowest terms is to get the lowest form. To get the lowest form, you need to use the largest number that will divide both the numerator and the denominator. I'm going to show you the previous example. In that case, if I had divided the 4/8 immediately by 4, by the greatest number, okay, because 4 and 8 are multiples of 4. So if I had to divide both the 4 and the 8 by 4, alright, I would have ended up immediately, alright, with 1/2, because 4 division by 4, it's 1, and 8 division by 4, okay, it's 2, okay? So if it's better to find the largest number that will divide both numerator and denominator, not because if you do it in steps it is wrong, no, alright, but because you can do it faster, okay? Because you don't need a lot of steps, but you just need one step, okay? In case you don't realize that there is a higher number, it doesn't matter, okay? Divide by a number, look at the fraction. If it can be simplified further, then simplify. If it cannot be simplified further, then stop there, okay? Now, simplify until the fraction cannot be simplified anymore, alright? We just discussed it. Now, reduce the following fraction to their lowest terms. We're going to discuss some examples together. Now, 25 on 30. If I look at the fraction properly, I realize that both 25 and 30 are multiples of 5. So I'm going to divide the numerator by 5. I'm going to divide the denominator by 5. Eventually I end up with 25 division by 5, it's 5. 30 division by 5, it's 6. I cannot find another number which divides exactly into 5 and 6, so that is my final answer, alright? You need to check that it cannot be simplified further. That's when a fraction is in its lowest terms, okay? Now, 24 and 36. Okay? Let's say that I know that they are multiples of 4. Alright? So I'm going to divide them by 4. And the 36 I'm going to divide again also by 4. 24 division by 4, it's 6. Thirty-six division by 4, it's 9. I look at the fraction 6 ninths. 6 ninths. Can it be divided by one particular number? Further, yes. 6 and 9 are both multiples of 3. So I had to divide again the 6 ninths by 3. Division by 3 in the numerator. 9, the denominator, have to divide it also by 3. 6 division by 3, it's 3. 9 division by 6 division by 3, it's 2, sorry. 9 division by 3, it is 3. Okay? 2/3 cannot be simplified further. I cannot find another number which goes into 2 and 3 also. So that is the final answer. I can do that, alright, by finding the highest number, because I did not find the highest number and I had to do it in 2 steps. So let's write it down. 24 all over 36, alright? If I think, alright, I realize that they are both multiples of 12. So I can divide the numerator by 12. And I can divide the denominator by 12 as well. Okay? In this case, 24 division by 12, it is 2. 36 division by 12, it is 3. 2/3, alright, I obtained a 2/3 as well, obviously, because both my methods are correct. 2/3 cannot be simplified further, and that is the answer. Okay, so today we also obtained equivalent fractions, but instead of by multiplication, we obtained them by division, right? That is called simplification of fractions, simplifying fractions, or reducing a fraction to its lowest terms. Now, your homework, boys, would be very similar to this lesson, right? Just in case you get stuck, you can watch the video again and try to work the examples yourself, and then go on. All right, if you understand them, then go on. All right, so that's all for today, boys. Good day and take care.